like to present Agentic AI for patient call triage system. Thank you so much, Applied Healthcare AI Summit team. I appreciate this stage and opportunity. What we'll focus in this particular topic is how current multi-agent framework are being used in healthcare centers and how do they efficiently triage all the inbound calls that they are receiving. Before suggesting any solution, I would like to talk about what is the problem that we are solving here, right? So currently we have 143 million plus US visits of patient yearly basis, and this number is growing at uh, most fast speed versus the clinical staff capacity. So we somehow have to solve this problem by utilizing AI as a triaging system. And clinicians, whenever they receive this patient call, this is the first point of interaction. And what happens because of the shortage of the clinical staff, they have to do multitasking and they have to make decision in high cognitive load. And that creates error of fatigue induced error and sometimes inconsistent prioritization because of a lot of pressure. So to resolve this or to help in this situation, we are introducing AI clinical call triage system, which will not be only auditable, explainable, but help the clinicians being there. And you know our goal is not to replace their judgment but help them to make more thorough judgment. Now, agentic AI, what are some of the backbone core principles that we'll be using in this solution? So, usually, when we talk about any AI solution, it's like one single model that is, most of the case, it's a large language model that tries to do multiple things at a same time. But with agentic AI solution, we are doing or taking completely opposite approach where we divide the full task into multiple subtasks, and one particular agent is more specifically knowledgeable to achieve or succeed in that task. Now agent task can be divided in for first of all data ingestion. What we are doing in data ingestion is like we are taking multimodality of data, can be voice, EHR, vitals, or historical patient visits, and one agent will be pro for this task, how to combine this data, how to get meaningful insight out of it. The other agent will take care of privacy reduction. So whenever we talk about healthcare or customer data, we would be making sure that the data is private and we comply the privacy rules. So we want to make sure the agent is um, very good or having high accuracy in detecting PII, PHI, and eradicating those from the patient data. The third agent can take care of knowledge retrieval part, where it try to not hallucinate and ground the response by saying which document it refer to and how did it come to this solution. Then there can be a fourth agent can take care of triage classification. So now this agent will make sure whatever whenever there is an inbound call, which route to triage it to or what should be the priority, this model will take care of that. And then there is explainability part of it. So whenever you come to solution, you use not only your accuracy score or your confidence score, but at the same time RAG based solution as a backbone to tell why did the model reply in that manner, what was the document that it referred to. So this overall system will have high accuracy, high auditability, and safety by design. Now, when we say accuracy, because here we have multiple agents that are in each specific task, high auditability because we can log after each response, so we know where exactly it failed or where exactly we need further improvement. And safety by design because now here we are following specific schema, we are guard railing or we are grounding the responses, and there will be always human in loop. So Whenever AI replies initially, the human will make correction if needed. Now we can also touch base on the architecture diagram of it. So as we discussed, there are multiple agents are pro for per specific task. The same goes for the architecture design. Here we see we all start with the input layer. Now, why do we need this many information for a patient call triage system? So we would like to first use voice whenever patient is calling in and explaining the situation. We might need speech to text translation model, so we need their voice to record what's their concern. EHR data can be helpful for us to understand what when the patient visited last time, what was their conversation with clinicians. Do we see any insight that the patient is having one particular disease that need immediate attention? Then we also want to make sure vitals information, what kind of medication the patient is taking day to day basis, and patient history that tell us uh, does this patient visit urgent most frequently, or does this patient can be taken care by staying at home? So we need those kind of input signals. Then there is a pre-processing to normalize, to fix the spelling errors, or sometimes removing some uh, characters or punctuations to normalize the data so that all data are in standard format. Then we use RAG-based system to connect these clinical documents, some hospitals websites or some APIs to make the system more compliant and reliable. Then there is a triage agent, which will make sure of LM reasoning, deliberation, and confidence scoring. So here we can add some custom prompt to let the model know what is your core purpose and how should you respond in this healthcare system. And then there is a prediction agent which predicts the classification score, the prioritization, and then decide which patient should route to which priority queue. Now orchestration. So here we are talking about each layer, but behind this layer there is a orchestrator that makes sure we are logging the system, all components are connected, all data flow are going in a direction it should be, and the system is safe, guardrail, and reliable. Now, let's also talk about we have seen the architecture more from bird eye view, but what if we want to see what each layer has major technology aspects connected to it? For example, foundation LLM. So, for foundation LLM, there are multiple large language models available currently in the market, but particular use case, particularly in healthcare, we also have some specific LLMs such as MedPalm 2 for clinical language understanding or differential reasoning. So here I have just named few such as Gemini 2.5 or GPT-4, but of course, based on the use case, we can select which foundation model we would like to proceed with. Then for RAG and vector database, there are some well-known solutions which are LangChain or Llama Index, or even for doing the data fetch or vectoring the database, we can use Pinecone or Weaviate for ground responses. So these are some of the technologies or solution that exist for each layer. For agent orchestration, we can use LangGraph or AutoGen for agent-to-agent negotiation, and for EHR and FHIR integration, since we have a high modality of data, we can use HL7 FHIR R4, which can you know um, very efficiently takes data from Epic MyChart or Cerner and combine all this data and create data that it's a systematic and exists in just one system. Now, for evaluation, when we build the system, we also have to understand how are we going to evaluate it? How do we gain confidence on our own system? So we can use some AI metrics such as ROG, Blue, But at the same time, we can use LM as a judge to correct whenever it's making error. So we use, for example, we use just the basic large language model, but we can use very heavy large language model to make sure whatever the other model prediction is it correct, is it compliant. If sometimes it going giving responses which is out of the scope, we should train the other LM to make guardrails on those responses. And then there is an SBERT for semantic alignment. So we can also see how semantic the responses is there is a semantic similarity between the question and answer, or its answer is completely unreliable. To understand even further, we can also take some real world example how this been implemented currently in real use cases. So I'm talking about Triage Agent system, which is a collaboration between Children National Hospital and Virginia Tech. What they were trying to build is a multi-agent LLM pipeline for targeting emergency severity index. Now, this gold standard, it's also used in US emergency department to understand what is the emergency of one particular input details versus the other details. So it gives a score between which one have a more emergency versus the other. And why it matters? Because it use multi-round deliberation. Now what is multi-round deliberation is rather than having just one agent making the decision, which sometimes hallucinate or give a response with overconfidence. Multi-round deliberation help us to have multiple agents come with the solution. And then there is, if there is a very strong alignment in all the response, the system will stop and give back the response. If there is somewhat misalignment, then system keeps on collecting the answer from the agents and come to a conclusion, which also replicate the real world where nurses try to make sure or come to conclusion of real critical workflows, or come up with the solution when patient or any inbound customer queries. Now, self confidence scoring. So, here, since we have multiple agents, they have a capability to intercommunicate with them and reduce some uncertainty between the output and come to a one final score. RAG over ESI handbook. So we use some materials like clinical documents that are knowledge graph for RAG based system, and we can limit the RAG to answer only from the knowledge that we have provided. And benchmarking result. So this system sometimes even outperform GPT-4 baseline on professional clinical data set. So we have shown that this system can not only overperform the role-based system, but also some own LM that are doing great currently in the market. We can also take another example, which is like CORTI agentic framework. Now, the goal of CORTI agentic framework is to have four modules out of it, like modular agent design, live EHR grounding, safety first schema, and replayable audit trace. So modular agent design is like discrete agent for clinical documents or guideline lookups. So their goal was to have a separate agent, each are specifically used for per use case. Then there is a live EHR grounding. So agent query should be replied with API mid call. So have ensuring the context is current and not a stale. So they wanted to make sure whenever the patient conversation is happening, the data should collect the live recording and should reflect the outcome of the model. And safety first schema. So they initially have human in loop. They also implemented reinforcement learning, and eventually they deployed it into production. And replayable audit trace. So whenever something wrong happens, they log the system so efficiently. So they exactly knew how the system is behaving, what was the actual behavior that they wanted to see, and where they need to improve further. Now there are some deployment challenges. So when we were talking about the issue that we would like to solve, we know that there are challenges in the existing solution, but we could not say that the new system will not have challenges. We might suffer for with these challenges with the new system solution as well, but that itself is very time efficient solution. It is completely automation based, so less human intervention is needed. But some of the challenges that we might see with the AI solutions are HIPAA and PHI compliance. So we need to make sure we are dealing with patient data, so we cannot miss even a single personally identifiable information. The model should not hallucinate, because whenever we give any recommendation to patient, our patient life is at risk. So we need to make sure if the patient needs to see a doctor, we make that decision right away. Legacy EHR complexity. Some legacy system, they are very difficult to integrate with the AI bot or AI automation. So we see some challenges on that side. And real time dynamics. So even though at one question we see the patient need to see a doctor right away, but the other question say, I still feel that my symptoms are very minor, I can still handle it. So AI should be able to take decision efficient considering all the real-time signals that it collects. Future direction and recommendation. So, assuming we have implemented this system currently in the environment, what are some of the future recommendation we can still think of? So, we still want to have more multimodal fusion, such as currently, let's say we are only considering voice, EHR, and patient history. How about we can also collect their cognitive images, or how about we also collect their natural language tone, how it fluctuating, how the patient is articulating their thoughts, so we can also understand the symptoms behind the scene that patient not even mentioned. Adaptive orchestration. So hierarchically multi-agent system, dynamic task scheduling, they are proactively adapt the new ecosystem, but we also want to make sure that this system can adapt what where it failed and how it can be fixed and what kind of decision it has to make moving forward. Continual learning pipeline. So we can use some AI techniques such as reinforcement, human feedback loop. Wherever model makes mistake, it should recognize it by its own and use their own prediction data as fine tuning for next batch. And then there is ethical governance and bias mitigation. So most of the time each region have their own government policy and their own ethical ways to doing things. So we want to make sure it is, if we want to deploy the system worldwide, we are following rules for each region wise. Also our system should be bias mitigate, which means it should be ideally for all race, for all gender, for all age group. And we want to make sure before even we deploy the system is performing well for all the bias categories. And conclusion. So what we have presented today is like transforming patient call triage system. Since we know this is the issue that persists for last couple of years, that we are lacking the staff that needs to attempt this call immediately. Sometimes patients stay in the queue, they have to wait for a long time, even they are suffering from one agent to the other, so they have to repeat their situation multiple times. So with this smart system we can build a solution that is scalable, explainable, clinical grounded, proven in practice, and considering safety first as its core goal to build the system. And thank you so much for listening. I'm open to answer any questions that you have.